All right, we've been talking about stoichiometry. Your first quiz, which you'll get back momentarily, assessed whether you could do simple, please put that down, stoichiometric calculations. Could you convert from moles of one substance to mass of another? The other day, we introduced the concept of limiting reagent, in which you were provided two givens, and you had to determine which given you would use to determine the theoretical yield, that is typically the mass in grams of a product. Keep in mind, when you're calculating theoretical yield, you must go after a product. Products get yielded. The last thing we want to do today to complete the chapter is to put it all together in regard to theoretical yield, actual yield, and percent yield. And you will be doing all of this in the lab. The actual yield component in the lab will be a little bit different than what you see here, but it still will be very straightforward for you. For example, let's say that you were going to take a remedial quiz. Remedial quizzes are typically out of 10 points. 10 points is your theoretical yield. That's what you should be able to get in a perfect world. In the laboratory, that would be the mass of one of the products that you should be able to generate. Let's say, for example, that you got a 9 on the remedial quiz. That's your actual yield. That's the score you got out of the 10. Your actual yield today will be the mass of the sodium chloride that you generate in the lab. You will mass it using the balance at the end of the lab once it has cooled. If you divide these two and multiply by 100, you get percent yield. In college, that's how you are graded in the laboratory. What percent did you generate in the lab compared to what you could have generated? And that's what we're going to look at today. Now, for a number of reasons, you may not get 10 out of 10 on a remedial quiz. Similarly, in the lab, if you're supposed to be able to generate, let's say, 2 grams of sodium chloride, and you only generate 1.8 grams, there are a number of reasons why you didn't generate as much as the equation predicts based on the amount of substances you were provided with. Some of those reasons are indicated here. The percent yield describes the efficiency of the reaction and really your efficiency. How good of a job did you do in the lab? Sorry. So the percent yield describes the efficiency of the reaction, especially your efficiency. How good of a job did you do? The actual measured amounts that react may not form what you predict for a number of reasons. One situation could be the laboratory conditions. It's especially cold in here. At very low temperatures, many chemical reactions do not operate as quickly, and that may affect how much product you generate. Some of the reactants may not be that pure. Did we use pure baking soda, or did we just buy it at Publix? That can affect the purity of the reactant, and that could affect how much product you generate. Sometimes materials are lost during the reaction. Now, it could be that you spilled some of your sample, or on the hot plate, you'll have to make sure that none of your product came out at the end. Sometimes it's difficult to get all of the reactants to react, and sometimes you have side reactions with other reagents or also with components in the air. So for a number of reasons, what you actually generate in the laboratory may not be what the equation predicts that you can make. So again, your theoretical yield is the amount of product. Be careful here, if you're yielding it, you're going after a product. This is the amount of product that's predicted to form based on your given and the balanced equation. Your actual yield is what you actually generated in the laboratory, and you'll get actual yields today because you'll mass out your product at the end. You're making table salt, sodium chloride. You calculate percent yield as shown here. Just remember you have actual over theoretical times 100. You'll be able to calculate the actual yield in most of these problems. Let me rephrase. You'll be able to calculate the theoretical yield. In most of these problems, the actual yield will be given, or it'll be the mass of the product at the end of your experiment. Divide the two, multiply by 100 to get the percent yield. We're going to walk through two big example problems together. These are very similar to what you will see on your quiz, which is slated for the next class period, not the half day. The example says potassium chloride can be prepared, so you're generating it, from potassium carbonate by treating the carbonate with hydrochloric acid. The other products include water and carbon dioxide. So the first thing that we want to do is we want to write the balanced chemical equation. This is probably a little tougher than what I'll give you on the quiz. What we have here, we've got potassium carbonate. In the lab, you're using sodium bicarbonate, reacting with hydrochloric acid. We're going to generate potassium chloride, which is a salt, water, and carbon dioxide gas. Writing balanced chemical equations should be second nature to you. Most of you did extremely well on the quiz. The beginning part of this is just like we did the other day, so there's going to be a lot of review from the lesson from the last class. So we have a balanced chemical equation. That's 1A. In B, it says that you have 45.8 grams of potassium carbonate, and you have 20.4 grams of hydrochloric acid. And you want to know which reactant is limiting. When finding a limiting reagent, what must you compare? Moles. Moles, 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 moles. So what you're going to do here is you're going to convert to moles. Guys, let's focus. 1 mole of potassium carbonate . Anybody need a calculator? Josh has the drawer open.
Yes. Give me up, ma'am. This.
We're going to convert both of these to moles. And this we did the other day. If you did your classwork through number 6, you should be very comfortable with this concept. If not, I highly recommend you do it before tomorrow, so if you have any questions, we can address them. So now I have moles of each reactant. But what else must I do before I determine the limiting reagent?
divide by the mole ratio.
Divide by the mole ratio. So divide by the coefficient. This you're going to divide by 1, so you'll get the same number out. This you're going to divide by 2 because of the stoichiometric coefficient here. And now you're going to make a comparison. You have 0.331 moles of potassium carbonate and 0.280 moles of HCl. Which number is larger?
Like potassium.
This one. So this is greater than this. So the moles, after dividing through by the coefficients, indicates that you have less hydrochloric acid stoichiometrically. And therefore, hydrochloric acid is the limiting reagent because, go back to your original given, 20.4 grams of HCl is stoichiometrically less than 45.8 grams of potassium carbonate. All right? And that will get you full credit through this point. We have already covered this. Writing the balanced equation, converting to moles, dividing by the coefficient to see which value is smaller. The smaller of the two indicates that HCl is the limiting reagent, and then go back and compare the original givens for stoichiometric proportions.
Is the mole in the equation like just one mole, like always? Or is
Here?
it in the equation, yeah.
This is always 1. Whenever you're converting from mass to moles of the same substance, you always have 1 mole of it. So now we know the limiting reagent. The next question in the note packet would be for extra credit. I'll walk you through this again, but this is not something that you're required to know. This would be more for advanced chem, although I think it's good to see at this point. It asked for the mass of unreacted excess reagent so you were given that many moles of it. That's the first conversion you did. We'll figure out how much of it reacts. If you subtract the two, you'll get the unreacted, and then you can convert to mass. And again, this would strictly be for extra credit, so don't fret over this. This is not the crux of our lesson. This we did the other day. How do we figure out how much of it reacts?
Take the thing, like since you divided it, you take that other, cause like you take the hydrochloric,
In this case, it's going to work, but you do have to be a little careful with that because if one of the coefficients weren't 1, it wouldn't work. But here it will work.
taking the HCl.
Yeah. If you go back to the limiting reagent here, so you have 0.560 moles of HCl. That's the limiting reagent, so you always start with that. If you figure out how many moles of potassium carbonate react with that given here, you are correct, because in this case you're going to have 2 moles here and 1 mole here. So by dividing by 2, you would have the amount that reacts, and I think that's where you were going. The only problem with that is if this had not been a 1 stoichiometrically, it wouldn't work. So be careful there. You're better off setting up a mole-to-mole ratio. But in this case, you're correct. It would have worked. So that's how much reacts. And how would you convert to mass then? You just do formula mass, and you already have that piece here, which is nice. So this really isn't that labor intensive because you already have a lot of the work done. And if you multiply those two, you get 7.0. You got down to 2 sig figs. I'm going to flip this over here so you can see it. 7.0 grams of potassium carbonate. And again, that would be strictly for extra credit. If you want to go back over it at the end, I'd be happy to do so. But I definitely want to be able to focus on the new piece of the puzzle today. So also from the other day is what C is asking for. C is asking for the theoretical yield, that is the mass in grams unless specified otherwise, of potassium chloride. So the theoretical yield will be the mass of potassium chloride. And what do you begin with to get the theoretical yield always? What determines how much product you can make? The limiting reagent. So you always start with the original given of the limiting reagent, either mass or equivalent moles, not after you've divided it. That'll make a mess. And in 2 steps, and this you already know how to do as well. From the balanced equation, you can convert from hydrochloric acid to the potassium chloride, 1 mole of potassium chloride to the mass in grams off the periodic table. I'm going to cancel those 2's because it'll make life easier. We have 0.56 times 74.551, and that's 41.7. That's our theoretical yield. That is the mass of product we should be able to generate. And you're going to do something grossly similar in your lab right here. You'll get the theoretical yield of a different salt in your lab from the limiting reagent. Okay? D is really the only new piece of the puzzle. In D, it says the actual yield, and they gave us this, is 38.2 grams, and we want to know the percent yield. We know that percent yield is equal to the actual yield, abbreviated AY, over the theoretical yield, abbreviated TY, times 100. The actual yield is given at 38.2 grams. What's the theoretical yield?
41.7.
You got it. That's, kids are like, well, where do you get that from? Well, you just got it. So 41.7 grams times 100. So you have 38.2 divided by 41.7. times 100 is 91.6%. And that is really the only new piece of the puzzle. The next big question we're going to do is very similar. Just want to put all the pieces together.
Can you move it up?
Do you put anything after, like grammars or anything?
I can't get it to go. Let me see.
Just back and stuff?
Is that better?
Yeah.
Okay.
Thank you.
All right. And we're going to do one more big problem from start to finish. And then if you do the rest of your classwork, I think you'll be very successful on your quiz, which is on the next block day. All right, we're going to take a look at the next reaction. Most of you are extremely strong at predicting products. You did a great job on the quiz. So we're going to walk through the next problem, which is on the screen. It says calcium reacts with sodium phosphate. So the first thing we want to do is write a balanced equation. And again, this you already have mastery of. You've got calcium reacting with sodium phosphate to generate calcium phosphate and sodium. Make sure when the metal gets pushed out, it's all by itself, no subscript, no superscript. That's the only mistake that some kids made on the quiz. In B, it says you have 152 grams of calcium and 321 grams of sodium phosphate. You need to find the limiting reagent. How are you going to do that? Convert to moles. We know that 1 mole of any element is equal to its mass in grams. So do I just compare those two numbers? No, I need to do what? Divide by their coefficients, right? And Faith, this will be an example. You'll see it right here of what's going to happen. So 3.79 divided by 3 is 1.26 moles of calcium. And 1.96 divided by 2 is 0.980 moles of sodium phosphate. Which quantity is larger? This one. And that makes which substance the limiting reagent? This one. The one you have less of. So sodium phosphate is the limiting reagent because, go back to the original amounts, 321 grams of the sodium phosphate is stoichiometrically less than 152 grams of calcium. That will earn you full credit on the determination of the limiting reagent. Now just be careful, in some of your classwork problems I made them a little harder than what the quiz will show. They won't ask you to find the limiting reagent first. They'll just assume that you need to, that you know you need to do that before getting the theoretical yield. I'm going to skip over the little I there for the mass of the unreacted excess reagent. I'll save a little space here for it, but I'm going to come back to that at the end, because that doesn't, you're not going to be assessed on that for anything but extra credit, and I want to make sure you're comfortable with the second half of it, especially what's relevant for today, because C, D, and then E. So C says, what is the theoretical yield of the element? Which element, look at your balanced equation, which element gets yielded? Which element gets generated? Sodium, right? You look at the product side, you look for the element, and that's sodium. So you're looking for the mass of sodium. That's going to be your theoretical yield. This is how much of it you should be able to generate in a perfect world. Where do you start? The limiting reagent. The limiting reagent is used up completely, and it always determines how much product, Andre, that you can generate. The other thing you want to be careful with is once you have the limiting reagent, which is sodium phosphate, make sure you go back either to the original given or the equivalent number of moles, not after you've divided it. And then this is a two-step problem that you've already been assessed on. And that's the thing on this quiz. There's really only a couple new pieces. Limiting reagent, using the term theoretical yield, percent yield, and we're going to link it back to volume in a few minutes. So you've got 2 moles of sodium phosphate to 6 moles of sodium, and this is a case in which I would reduce. I think it'll make life easier. For every 1 mole of sodium, you have 22.990 grams of sodium. And that's 135 grams of sodium for the theoretical yield. Now D says that the percent yield is equal to 74.79. We want to know the actual yield. Well, we know that percent yield is equal to actual yield over theoretical yield times 100. Can we manipulate those variables to solve for actual yield?
Yes.
Sure we can. The actual yield would be the percent yield over 100 times the theoretical yield. So we'll move the decimal 2 to the left, same thing as dividing by 100, and we'll multiply it by our theoretical yield, and that gives me 101 grams of sodium. Now in your lab, you're going to do actual yield a little differently. You're going to get it from the data. You'll mass out your product at the end. Devin, don't break my box, please. I have changed D in your notes. If you didn't quite get D down, don't panic. E reads a little bit differently here. I want you to copy down E, and then I will go through it with you. I wanted it to be a little more challenging to make sure that you would be able to handle anything that I gave you. It says calculate the theoretical volume of the compound that gets generated. Look at your balanced chemical equation. What compound gets generated? Calcium phosphate. So if we're looking for the theoretical volume of the compound that gets generated, then we're looking for centimeters cubed of calcium phosphate. That's what we're solving for. And if it's the theoretical volume, what are we going to start with? Whenever you figure out theoretical yield, whether it's a mass or a volume, you always, always, always use the limiting reagent. So we're going to start exactly where we did previously. And this is the same type of volume problem that we did a couple days ago. Whenever you're given moles, your first step is always going to be the mole ratio, which allows you to convert from one substance to another. Again, those numbers are coming from the coefficients in the balanced chemical equation. And now we need to go to mass and then finally to volume. So this is a mole to mass conversion for calcium phosphate. I'm going to pull this one up here because it's getting squishy. Calcium phosphate we use in the lab a lot, 310.18 grams per mole. And then this piece you already know how to do, but you may not be remembering. How are we going to go from the mass of the calcium phosphate to the volume?
Density.
The density. So we know the density of the substance is 3.14 grams per cubic centimeter. So if grams are here, the 3.14 grams of the substance go in the denominator, and 1 cubic centimeter of the substance goes here. This really should be written in a landscape portrait. That's why it's so squishy-wishy. So we've got, be careful here, you have more than one quantity in the denominator. You have 1.96 times 310.18 equals, divided by the product of 2 and 3.14, and that's going to be 96.8 cubic centimeters. So this is how I could link volume to limiting reagent. Again, use your limiting reagent. We can go back and do this if you want, or you can try it. Make sure you use your limiting reagent. If you start with moles, you will do a mole ratio to convert to the other substance. Then it's looking like a mole to mass problem. And then finally, you use that density factor that we talked about the other day. You'll use the density factor that we talked about the other day in the last step. Right here is your density factor. If you're solving for volume, it's actually the reciprocal of density. And you will have the volume of the substance. You want to make sure that you're comfortable with theoretical yield, percent yield, determination of volume. The quiz is grossly similar to this last question. You now can do all of the classwork. I strongly recommend that your classwork is done by the half day, which is tomorrow. The lab will further help you understand theoretical yield, percent yield, actual yield, and all the calculations that go with it. And that should help you understand the whole chapter on stoichiometry in more detail. Questions here? Okay.